Hi, this is Chris McElligott Park from Arkin Games, back with part two of looking at the threading model and multiplayer model. And this is going to be the last video that I'm really planning on doing on this subject, but I'll take questions on Discord and so forth if need be. And if there's information that I need to make more clear again, then I'll make a third one. But the idea with this one is we want to define how your code specifically, if you're making a mod or you're working on designing a faction, what are you allowed to do in terms of having data move around or altering data in some fashion? What constitutes a desync, and what is okay? Now, I gave one set of answers to that prior to the Great Refactor that came out or that's still in beta, but came out like a week or two ago. And I'm going to give you a different set of answers now. So if there is something that conflicts with what I'm saying now that is from earlier in 2021 or prior, this new information is the correct information, because information's changed, Jim. Or the situation. All right, so what is a desync? Really, really briefly, for our purposes here, obviously a desync is a discontinuity between the client and the host. In other words, the client and the host are seeing two different things. However, that's not specific enough for our purposes. For our purposes, we need to remember, based on the first video, we are in a constant state of semi-sync to begin with. This is not a deterministic simulation. It's close, but it's not. And it has floating point errors. It has all sorts of things that will make it non-deterministic. It'll have modder errors from programming, or we may make errors ourselves in programming internally. It doesn't matter because it self-heals, and so we are not worried about that sort of thing. So what could possibly be a desync in a self-healing system, and why do we care? The reason why we care, there's two reasons why we care. One is rubber banding, and the second is bandwidth. So rubber banding is what happens when something seems to start happening on the client, and then it jolts back into place. And often, if there's rubber banding going on, it'll take on a repetitive fashion. So on a client, if there's a really annoying sort of desync going on that's not just like a little temporary fix in data, then what you'll see is, like, for instance, one ship drift off to the right and then zip back, drift off to the right and then zip back, drift off to the right and then zip back. The second thing is that every time it zips back, that's like, I want to say like 30 bytes or something like that of data. That's not a lot. But what if we have 2,000 ships that are having that sort of drift and zip back? What if we've got 5 clients and a host, and we've got all these, sync correction stuff that's happening repeatedly, almost harmonically, over and over and over again? It's not the end of the world. I optimized the every aspect of sending data so that it's less CPU intensive and less bandwidth intensive. So the idea is that it's not supposed to be the end of the world, but let's try and minimize it, because for our edge cases, places where there are people with extra long distances between them, or they just have a spotty connection in general, their Wi-Fi is kind of dropping in and out, whatever the case is, let's go easy on the bandwidth when we can. The more concerning thing most of the time, and again, more to the point of why do we care about bandwidth, is that the client may wind up experiencing little hitching and delays, and then that would also potentially move over to the host and also have them going, waiting on client, we're back, waiting on client, we're back, wait, and so if we're flooding them with like desync data, that could lead to that sort of issue. The rubber banding The reason why a repetitive rubber banding would happen is because the client thinks something is supposed to happen in its simulation, and it simulates that over the course of however many simulation frames, probably about 20 or so. And then the position is off. It's noted by the host and the client, hey, our positions don't match. So it sends the Wolverine healing data from the host back over, and the client's caught up to speed. Everything should be great. And then the client does it again. And why is that happening? It varies, but generally speaking, it is the client running some sort of code that's like, go chase and shoot this thing that's over here against some phantom object, or it's just running something that is like, go heal this thing over there. It's making a choice drastically differently from the host, and it's doing it over and over and over again. And so those sort of things where we get kind of the wrong sort of data stuck in there, that causes the rubber banding that we want to avoid. A one-time rubber band is less of a big deal, but visually it still feels weird if you're the client. And a one-time rubber band is where you give some orders or you don't give some orders. Some ships come in, whatever, it doesn't matter. Ships are moving around, and some of them seem to do something, and then they flip back over, and everything's normal after that. Now, that is a much less serious case, and that's just it being Wolverine and healing. But essentially, that's you seeing the wound, and we would like to not see the wound. So there's a thing that you can call on the host if you know you're calling something that is going to cause a divergence. In other words, you're giving host side orders to a unit that is going to cause it to drift off path from what the client would think. Then you can call a thing that says mark as flagged for forced sync to client, I think is the name of the method. So basically, we're proactively saying from the host, if the client doesn't know, tell them I'm making this change. The client will proactively get information on, I don't know what's going up, but you need the full information about this entire unit and everything that's different, everything that's on it, not just its position, not just whatever, but full core info and full base info about that specific squad that the host has updated. And when you do that, that means that you don't wind up with even the temporary rubber band, because the host has communicated to the client, hey, a major change has come to this particular unit. I wanted you to know. So how do we cause problems and how do we not cause problems? Number one easy way to make a problem is for something in the UI thread, which is not the same as the sim thread here, to go, I mouse click on the host or the client, especially on the client, and say, your position is now directly over here instead, or you have new orders that I have given you, not through a game command, not scheduled, not known, but I'm just directly giving you some orders, or I just directly changed some data on you from the UI. That's a desync immediately. That can happen on the client, on the host. You can easily do that in a mod. You just go in and you just say, its position is now this. I'm coding in a custom knockback, and it works great on the host. I see them getting knocked back because I'm calculating per frame, how the knockback is going to go or whatever. If you were to code a custom knockback like that and you put that on deep info, or you said this only runs on the host and you did it on base info, or you used the central permanent random number generator, but you still did everything else right on base info, you've got a desync. So let's suppose for some reason we had like a custom knockback mod feature, and that when a ship gets shot by your custom thing, then the ship gets knocked around in some way. There's only two ways to really do that. If you were like, if let's say that if you wanted to have it so that let's make the really simplest example. Actually, it's not something random. It's the mouse click. Let's make a mod that means whenever you click a ship, it gets knocked physically away from the cursor. You could do that. If you do that, the simplest way to code this is detect when the mouse cursor is over a unit and when it has a click, and if it is clicking on a unit that is yours or an enemy unit, your choice, or a unit is newly selected, pick your criteria, then it moves the unit. It sets like a knockback flag on it in, let's say, base info. We don't really care. It says there's a knockback flag on it, and then over the next few frames in base info or whatever, it's going to keep moving it away from the position that your mouse cursor was at. Well, if you directly set any of that information on base info from the mouse cursor, your that base info is essentially considered part of the main sim. You've just created a desync. It'll always be a desync. It'll always work perfectly in single player. It'll always look perfect on the host. It'll look perfect on the client when the client does it, but the host won't see it, and the client will see a rubber band effect of it getting pushed back to where it was. Also, on the client, it'll wipe out the base info when it gets the sync data from the host, so it won't repeatedly rubber band, but it will rubber band. So that's one example of a way that you can introduce a problem. How would we properly do that? Well, the proper way to do it would be to have, when we click in the UI, have that create a game command which gets scheduled, and then it will have a slight delay after your click. Unfortunately, that's just the way it goes. Clicks are not as there's a time delay on clicks. There's not a time delay on a lot of other stuff, but because of the game command structure, if you're going through that, you've got it maybe a 400 millisecond delay if you're on the client. So then in base info, since this is a mod, you would process the game command. The game command would set some data on the unit, and then it would start moving the unit away. And I'm not drawing a direction as if the unit was moving. I'm not actually referring to short-term planning. But then you would move the unit away from that position. So that'd be the correct way to do it. But if we're moving it in a random direction, then how do we do that? Like, what's okay random-wise? Okay, so there's two answers to that question. If you calculate the angle that the unit is going to be knocked back in before the game command, so before the game command goes in this queue at all, you basically look at the position of the cursor and then it relative, I don't know, to the center of mass of the unit or something, and then you make an angle there, or you just choose let's say we just choose a random direction. You click on it, it goes in a random direction. If in the UI you want to choose a random direction that you will then feed into a game command, there's only one proper random to use, and that random is engine universal dot permanent quality random, and you just say next, and then use that to get to calculate your angle. You can say next 0 to 360, or you can do from a list, whatever. This permanent quality random in Engine Universal, this is completely non-sim. So from the first video, I talked about like the example of like random like bird calls and stuff like that. This is what you would call for that. There's the inverse of the bird calls problem, where if actually, this is the same as the bird calls problem at the moment. There is an inverse, but that's not what I'll talk about the inverse in a second. So if here you were to use wherever you are in the code, let's say you're in some code somewhere and you've got a context. This is not useful code to be in. If you are in base info code like this, and you've got yourself a, oh, I got like that one just doesn't have any. Here. You've got stage 2. You've got a context. If you hit context dot random to use dot next 0 to 360, let's say, and you use that to populate a game command you're sending on the client or the host, it doesn't matter. You've just introduced a desync because now you've used a simulation random, that's what this one is, and you've done a non-simulation activity with it. A non-simulation activity can be misleading to think about because think about it, anything that a player does, like a mouse click, that's non-simulation. We are not simulating you, so you're not part of the simulation. The mouse clicks that you make either just mess with the UI or they become part of the simulation in the future, because when I click the mouse, it doesn't become part of the simulation immediately. That'd be a desync. Instead, I'm being inserted over here as a game command. The game command will be part of the simulation, but my mouse click directly is not. So if I'm calling a random number generator in association with my mouse, then I need to use the proper random, which is the engine universal permanent quality random, not the context random. So what if we did it on the other direction though? What if the randomness of the, so we've got game commands here. What if we click in the UI, we generate a game command, and then we don't say what direction we want it in though. We just say explode in a random direction. This could be decoupled from mouse clicks. We could just have explode in a random direction. Game commands just randomly get, well, some sort of trigger that's host only, I guess, or driven by a specific client, doesn't really matter, get attached to units. If we did that, then in here we have a context. We need to use the context of the game command. If we used engine universal dot permanent random, that would be now the opposite, the inverse case of the bird calling. So in other words, we would be using the non-sim random for a sim purpose, because anything that's going on in a game command, if it's in base info, it is sim. If it's in deep info, then it is technically still sim, but what you're going to wind up with is this. If the desired status is client, then return. And so effectively this becomes non-sim at this point. Now, the context that's being passed in, you can still use the random for, but you're really going to want to get the host only context because that has a separate random number generator in it. And if you get the host only context, you can safely use that. And the reason why we have a host only context versus just calling to the non-sim random number generator is because, for one thing, there's more to the context than just random number generators to begin with. And sometimes we also pass in a context, which might be host only, client or host. We don't really know. We set it up so that it can be any kind of context is being passed in to a worker method, and that worker method uses the random on whatever the context is. If it's host only, it'll be deterministic-ish there. If it's client and host, should be completely deterministic. So those are ways you can mess yourself up with the random number generator. If you gate something behind a, hey, don't do this on the client type code like this, the other one would be, there's a moddable game command execution method here, and we could gate ourselves here. We do gate ourselves here, actually. But basically, this would say, let's see, we're at outguard faction. Yeah, this says if context equals null, then return on the client. Now, when I was looking at the AMU mod, I talked about this some. This is a way for you to know, oh, this is a host-only method, return. So if you've got any calls in here, it used to be that you could accidentally introduce a desync, and we frequently did, because it was a client and host context that was being passed into something, and then you would call random on that, and boom, butterfly effect is all over the place with a bunch of units, and you get a bunch of rubber banding effects from that. That was a way that we got weird data prior to the Great Refactor, and that was one reason for the Great Refactor is, this was one tiny part of it, honestly, but so that is one way that we protect ourselves against accidental goofs. Is if you've got something that's meant to be host only, it's better if you make sure that you've got a host only sim context being called in here, or a long range planning, which is also host only. And that's a deep info thing though. Deep long range planning would be these threads, which only run on the host. And so those have their own randoms. You don't have to worry about those being out of sync on the client or getting off by one in the number of random calls you've made on the client, that sort of thing. Those would be what, kind of the equivalent of the bird call or the inverse bird call desync state. So that's probably the number one way that you can accidentally have a desync happen, where it's a little bit invisible. Because if we had a host only thing and we used a client and host random number generator for that, that's a desync. It will recover, and you may or may not see any rubber banding, because it may just be something that affects interior numbers about how much loot this particular transport is carrying or something. I don't know. And as soon as the client mouses over that unit to see what sort of loot it's got in its transport, they'll see the proper loot, because that does an immediate force sync once per second when the client mouses over it. So when it's internal stuff that doesn't affect position for a ship, no problems. So it's fairly robust in that regard. Mistakes aren't the end of the world. I don't want people to freak out about it. Like if you're trying to mod, you know what I mean? But keeping them to a minimum, or just having an eye out when you're looking through your code and being ready to fix stuff when you see, oh, you know what, this should be host only, or that can make a big difference. And I tried to put up guardrails as part of the refactor to make it harder to make that error, if that makes sense, because it's very easy to make that error. Unfortunately, some of the guardrails, like the fact that you can just call engine_universal permanent quality random, you can call that from anywhere. I can't put up a guardrail around that, because you may need to do the equivalent of making a bird call in the middle of anything, right? Because you might be about to generate a game command for some reason, and you need a random for that. And if you're generating a game command, you're doing some sort of logic only on the host, probably, or you're doing it only on the client in response to client keyboard or mouse input. So, or on the client in response to some sort of logic that says, I only run on the local player's machine, which the local player's machine would be the player who is sitting at that particular machine. So each client would run their own logic for that in that particular case, and the host would run their own logic for it as well. And in that case, you could generate game commands off of an automated process, but based on they're sourced from clients, which is unusual. We don't usually structure it that way, but you can. I don't know that you necessarily want to, but if you were doing something based off of, for instance, the local personal settings of a client, that'd be a great reason to do so. I made the personal settings network enabled so that the host can find out what certain network settings are on clients if you flag it as network attached. Then that's a new feature that we have as of about a month ago, because before the Great Refactor, there was not a good way to do stuff only on the client like what I just described. Now you can do that again, and so you may not want to send the settings from the client to the host to make them aware. It's up to me. It's up to you. You can do it either way. Both ways work, and both ways are valid. But now let's talk about things other than random number generators, because there's code that's operating on all this stuff, right? And there's two types of code. There's non-sim code, which I was just talking about, and that basically non-sim code includes the UI, mouse and keyboard input. Those aren't simulated. Those are inputs to be inserted into the simulation. That includes possibly some non-sim worker threads. You could generate something out of there, like if it was like looking at your personal settings and like analyzing the game state and saying, oh, you know what, I'd like this person has said they want 5 engineers on each planet, and this planet only has 4, so build an engineer there. And then you put in a request for a build. We need to generate a game command. So you could have game commands generated from there. Long-range planning thread, that is also non-sim. That is the AI or the other factions thinking, and they generate game commands and they send them out. If they directly insert data into the main sim thread or base info, core game info, if they change anything in there directly on purpose, that is a desync. If it's on a squad, if it's on a faction or the world, we're going to need to talk about that separately in a minute, because there's an edge case here. And it's actually not such an edge case. But last one is the long-term continuous threads. Those also are non-sim. These ones are things that, like the decollision, stacking, all that sort of stuff, they generate game commands after that. They don't actually just execute the stacking. That would be problematic. So those ones need to generate game commands. All this other stuff can do things a little more directly. So at this point, it's assumed that whatever happens in here and whatever happens in here and is going to be essentially the same, well, specifically whatever happens in here. It's assumed that whatever happens in these bits there, those orange bits, are going to be essentially deterministically the same on the client and the host. There will be some drift, floating numbers, all sorts of other problems, coding errors, whatever. It's assumed that it'll be close enough, and then whatever the little errors are, for whatever the reasons, that'll get sorted out by all of this. In this sort of thing, you want to make sure, obviously, the random number generators to use is the context of wherever you're at. You do not want to generate a game command. If you generate a game command from here, then what's going to happen is, for one, it's going to introduce a delay of several sim steps. So maybe 400 milliseconds, maybe 200. I don't know. It depends on where you are exactly in the process. It's rolling. It varies, and it depends on if you're the client or the host. So that's situational. For one, there's a delay, and for two, unless you wrap it with if you're on the host, or if it's a local person thing and this belongs to the local person, something like that. If you don't wrap it in something like that, then you're going to get one copy per player of the same command being issued. So you'd get, if you've got like 3 clients and a host, you're going to get 4 copies of that game command. Don't do that. For 1, bandwidth. For 2, weirdness in execution of it. So game commands in this area are a big no-no. We don't want to do that. And so in our orange areas here, we are intentionally directly moving cheese around. Who moved my cheese? I did, because I'm allowed. I'm orange. And so in our light blue sections, we need to have that extra step of the game command. In these orange areas, we can directly touch. Now, with that said, now let me talk about the exception to this, because probably if you've been modding for a while, or if you were a faction designer like what Badger's been doing for a while, the stuff that I've told you so far in this video, for the most part, you already know. Here's where things get interesting. Let's have ourselves a green, because I'm going to leave this up. Okay. So we've got fast blast. So we've got our game commands. We already knew about that. This is something that is outlined and identical in this 1500 Archers article, which is a great one to read, and they explain it in great depth. There's no reason for me to here. So you're expecting that sort of thing. That means you should essentially, from a non-sim context, you should never have non-sim logic or inputs affect the sim, right? Not always now, because of this. So here's the deal. We've got a simulation process, a sync process that happens 2 ways. 3 ways. First of all, we have fast blast data. If it's a unit that's getting created directly on the host, client's never going to execute that. So if you call squad.create or shot.create and you pass in some information on the client, it does nothing. It's a dummy method. It's the same method, but it just returns nothing. If you're on the host and you call create a squad, let's say you did that in long range planning. If you were to call squad.create over here in long range planning, or you were to directly call that from like the stacking logic over here, on the host, it would work. And on the client, it would get fast blast data, and it would also work. They would be slightly off in time, but fast blast data already is slightly off in time. It would be more off in time, this one, because it would be, instead of being like part of a sim step ahead in time, it would be maybe however far ahead the host is running than the client. That's how far ahead it would be on there. So it might be like 200 milliseconds. It's really kind of hard to say because that all depends on timing and network latency and other factors. But let's say it could be as many as 100 milliseconds to, on an extreme case, like 900 milliseconds ahead of what it should be. And it'll sort itself out. It's Wolverine. It'll repair itself. But we don't want it to have to. Now, what I just said, though, about it working just fine to call that from long-range planning, that actually is technically a lie, because if you call create a squad from long-range planning, it'll probably work. But if you call it enough, or really one call is all that's required, but it's just if that call is run enough, eventually you're going to get cross-threading errors on the host, not on the client. So you will wind up with a threading error on the host sometimes by doing that, because that thread is really not supposed to write to that sort of method. But assuming you're doing things in a thread-safe way, if you wanted to, there's a lot of thread-safe methods and so forth. So you could do interlocked.exchange and change the number of stacked units in a squad or change the squad's health or something. And then you could do mark as needing to be synced to clients from long range planning. And then you could directly alter stuff from there. And that would technically not be a desync that you've introduced. It would be thread safe. It'd be kind of weird. I'd prefer that you didn't for architectural reasons like that. That sort of code confuses people. They're like, is that a bug? Like, what's going on here? Why is this happening? If you find you absolutely must do something like that because your code will be much more difficult to read if you don't, then comment why you did that, why this is not a problem. Hi, this code is about to directly alter some stuff. This is why I'm doing it. And note that we're calling mark as a force sync to client, so this won't create a desync. Thank you. And anybody who sees it knows that it's not a desync and knows why, because it's weird code if you do it, but you can. Here's the funny thing about that. If you make changes along those lines, it's really one game command that you generate from long range planning is going to have less data than making some direct modifications to a squad and then putting a game command in, sorry, not putting a game command, and then flagging it as needing a full sync. But we're talking about the difference between like a couple of maybe 30 to 50 bytes depending on the squad, and like 10 bytes or something for it's really, really small for the game command, depending on it. I mean, these things get compressed down quite a bit. So it is more efficient to use the game commands in this case, but we're going to get into now some weird cases where it's actually more efficient if you break the rules. So break the rules. This is what we're going to talk about next, is stuff that's not fastblast data, but instead stuff that is this. Because fastblast data intersects also with the squad sync data, and syncing a squad is something that only happens normally when there is an actual divergence. Does that make sense? So we do polling through, we find a divergence, we send a sync over, or the client hovers over something, we send sync over for that. The host says, I made a change proactively, I'm going to force a sync, we send a sync over. Those are the only reasons why squad data gets synced over after the initial world transfer. So if you introduce a bunch of extra squad syncs, either by causing desyncs repeatedly or butterfly effect of a bunch of desyncs from one small change and it affects a bunch of squads, then you just increase the bandwidth usage and probably cause some rubber banding. But that's specific to squads, because most data in the game is squad data. The vast majority of the save game is in or on squads. That's where most of it lives. Just because there's a lot of them, and as much as we compress down the data, there's still a lot. On these other things, worlds, factions, and fleets, and so forth, they are synced on various intervals, but it's within a couple of seconds for all of them. As it says, within 5 seconds, but usually it's closer to 2. And so let's think of another case here. Let's say you've got something in deep info, but it is stage 3 in deep info, and you want to change the allegiances on the faction. Now, this happens a lot, actually, in actual code that we have. There's an update allegiances thing based off of some criteria, like what the player's doing, or if something has changed, if there's been a hack or whatever, like an in-game hack, then it responds to that and changes the allegiances sometimes. That's often done in stage 3. When that code was originally written, the programmers who were writing that code thought that was going to happen on the client and the host, but it doesn't now. We could move that so that it happens on the client and the host, and that probably would be nice, actually. But it's not a real crisis because it's changing faction data, and faction data itself gets synced really, really frequently. Some of the core of it gets synced, like the allegiances part actually, gets synced every sim frame. So it's going to be to every client within 100 milliseconds or so. They get sent in batches, so actually I think it's closer to like 200 or 300 milliseconds, but really fast is the bottom line. So it's going to be difficult for there to be too much of a cascade of errors, of butterfly effect changes to squads and things. If you were to change the allegiances there, it is possible that if you change the allegiances on the host and you just do it on the host in here, and then that's going to affect squad behavior, that on the host, some ships start shooting at some other ships 300 milliseconds earlier than they would have on the client. And then you've got to sync repair all of those ships. So you see a little rubber banding on the client. The rubber banding that the client would see would be fast blast data would be coming in for those shots no matter what, and those would already do the right thing because shots are all generated on the host, so they wouldn't miss the shots coming out. Well, that's nice, but they would miss that their ships like stopped and moved into firing position if they're needing to move. If the ships aren't needing to move but they're still firing, then the only thing that would be missing would be the firing cooldown information on the client. That'll be slightly off from the host, but as soon as the client moves their mouse over the ship in order to see the tooltip where they could possibly see what the cooldown is, it will sync itself and it'll be correct. So the act of looking at it makes it correct. So for anything that doesn't affect the position of the unit, even if it affects the unit's firing, it doesn't matter. So that's kind of cool, actually, because that gives you some latitude to make mistakes without it causing a spike in bandwidth. When it comes to the allegiances example that I mentioned, that's something I'd prefer, honestly, move into stage 3 on base info, because base info has a stage 3 and deep info also has a stage 3, and you can run certain things host only or client and host. And for things like allegiances, if it's easy to calculate, yeah, go ahead and put it in there, because that's going to affect the behavior of a bunch of squads, and you might get some rubber banding, you might get a little bandwidth spike. Let's not, if we can avoid it. Let's think about a nastier case now, and that is attrition. So there's a lot of factions that have some units that are out and about, and they do some things, and then once they're no longer needed, and what that means is really faction specific. So for instance, in Astro trains, there's a concept of a train guard, and if the guard still is alive, but the train it was supposed to be guarding has died, then the guard will start attritioning. There is nothing in core that knows anything about a train guard or any sort of guarding or attritioning, this sort of thing. That logic does not exist in there. That logic exists only in external data, either base or deep. Where do you put it? Well, if you put it in base, everybody should be able to see that the guard has that the train has died, and therefore that the guard is attritioning. So the client should be able to easily do that in stage 3 of base info, and it'll be nicely in sync. Things will attrition on down. Worst case that could happen with that is that the client for some reason thinks that the train is dead, but the train is actually still alive, and so it starts attritioning a guard that shouldn't be attritioned, and then the host goes, here's your train, and puts it back, and then pretty soon there's a desync noted on the health of the train guard, and so then it goes, no, it's at full health. What are you doing? And it sends that back from the host, and so you would see on the client the health bar goes down a little bit on the train guard, and then probably for some reason the train was missing, and so then the train would reappear, and then the guard would heal back up, and that would be Wolverine kicking in. The worst case is if you don't put it in base info. Instead, you put it in deep info. And then you've got it attritioning only in here. And actually, there's still some examples of that in our actual code at the moment. I just haven't moved them yet. That's on my to-do list. And what happens there is it's like every second remove like 1% of the health or something like that of the train guard. If it's missing its train. If the host is the only one that runs that, then that means that the client is going to notice. So that would take, in that example, that would take 100 seconds to get rid of the entire train guard because, once per second we're removing 1% of health. The client would notice 50 times during that, because every 2 seconds it will notice. The client will notice 50 times in that 100-second interval and will say, something off with the health. Send it to me again, would you? And the host says, yeah, here you go. Here you go again. Here you go again. Here you go again. 50 times sending over the 30 bytes or whatever it is for that stupid train guard that's attritioning. And so that's like the least efficient way possible that we could possibly attrition a unit, and that will just send a flood of constant things. If you've got a bunch of things attritioning and it's all happening in stage 3 on deep info, ouch. I mean, it's not the end of the world because the data is as compact as I can make it, but it's still going to sync for that train guard. It's going to sync whatever the core data is for the squad, and it's going to sync the base info for the squad. If there's deep info, not going to sync that, but that's a bunch of CPU, and there's a bunch of work we don't need to do. We don't need to have processing. So just by moving that over, and that's a repetitive action. That once per second we're attritioning this thing, and so that's a particularly egregious case. Anything that's not repetitive like that, if you make a mistake and it's like, there's a special ability where when it went into a planet and I don't know, it loses half its health for some reason and causes like a big EMP burst or something. If you put that in stage 3 of deep info, then for one thing, the EMP burst, if you don't have that happen on the client as well, then the client's going to think everything's okay, and the EMP burst is probably not going to adjust the position or the health of any of the other units. And so the client's going to see all their units looking like normal while the host sees them as looking paralyzed. And as soon as the client hovers over something, it will become paralyzed. So as the client moves their mouse cursor around the battlefield, they'll have this wave of paralysis that seems to follow their mouse cursor. It's very surreal. And so we kind of like to avoid that, where instead we have some big effect like that either happen through a game command, but you don't necessarily have to, and you wouldn't want to trigger that off usually that'd be a long-range planning thing that would trigger a game command. We're supposed to be sim here, and so instead just move that into, if you can, move that into stage 3 of base info, trigger the EMP thing. The client and the host will see everything with the stunned effect properly right from the get-go, and the client's not going, what do you mean there was an EMP? It seems fine. Oh, weird. Look what my mouse cursor does. And if we took away half the health, though, as part of it, as like a one-time deal, if there wasn't an EMP, there was just like a penalty of whenever you move this unit into a new planet, it loses half its health every time. Whatever its health is right now, it gets halved every time it goes through a wormhole. If that was something we did that in deep info stage 3, that's really not a huge crisis for the client in particular, because they're going to see it with more health than it really has, and then within 2 seconds it'll be noticed that it needs to have the health drop down. If it was something like cloaking points or some other metric that's not health or position or number of squads inside it, it's not going to be noticed by the Wolverine model. It's not going to be noticed by this until it affects one of those other metrics. So the fact that something got decloaked won't be noticed until that thing gets shot. Which, again, because of fast blast, because shots are generated by fast blast data, the shot will appear on the client whether or not the client knows to shoot, which is handy. And so things will sort themselves out more quickly without you having to worry about it, because that shot will still appear on the client, will go and hit the ship on the client, and at that point the health will go down some. And worst case in that scenario, the client will go, why is my cloaked ship being shot? I can see this being shot. What's going on? And it's not going to be synced from the host, because the health will be in sync. It'll be proper. But if the client mouses over it like, why are they shooting? Then you'll wind up seeing that same sort of, hey, this is reacting to my mouse cursor. Weird. When I mouse over it, it corrects itself to being not cloaked. So you get into some kind of weirdness when, based on the way that it's all set up, if you do things in non-optimal places. But one of the ways that the client can look most wrong most repeatedly is when there's complex logic that's dependent on data that the client may have that's slightly stale, and the client therefore keeps making a different choice. So for instance, a good example with that would be, let's stay with cloaking. If a potential target has that's controlled through, I was going to say you might have some pursuit mode stuff that's controlled through long-term continuous on the host. That couldn't happen. Let's see, how can I break this? Most of those glitches would be visual, honestly, because all the auto targeting and stuff, it's controlled by the host. It's hard to get a client to rubber band too frequently, again, because the main way for client to rubber band, if it's wanting to shoot something, is if it has the long-term continuous thread will provide a list of targets, and if the client goes, oh, this first target's invalid, let's go down the list. Second one invalid, third one's valid, fourth one, okay, we can go for that, and then starts heading towards the fourth target. There's where you get into a problem, because then the host goes, hey, where are you going? That's a wrong position there, bud. Syncs it back over, and it's giving you the full list of 10 again. And the client goes, well, you give me this list again, and the first one's invalid, the second one's invalid, and on to the fourth again. All right, well, here I go. And the host is like, seriously, what are you doing? Meanwhile, the host is shooting at the top, the number one target, or moving towards the number one target. That sort of thing, when the data is stale to the point where the client thinks that the target that the host has in mind is invalid for some reason, that can cause rubber banding. It's much easier to have that happen with engineers, because the engineer logic happens in the short-term planning thread on the metal outflows logic, and then that's where it chooses what target to go for, and then it actually executes that on this main thread here. And so actually it kind of initiates it here, and then it further implements it on a movement thread here. So but at any rate, you can get engineers that rubber band far more easily than combat ships, because of where their logic originates from. I guess in theory I could move the engineer logic over into here, and then we wouldn't have that problem, but I don't think it really is too much of a problem too frequently, and unless you're coding custom engineer logic of some sort, it's the sort of thing that's a me problem, not something you need to worry about. So I would just fix the engineer central issue, and then that would be that. But if you need to change the name of a faction, which again, this is handled through automated central game commands already. So if you need to change the name of a faction, there's already a thing for that, but you just call that. But If you were randomly renaming a faction from one of these other threads here that are host only, and you adjust this faction information or fleet's information here, it's going to be updated really, really soon on the client. And if it's not something that affects the simulation, like there's no ships that go like shoot any fleets named Steve. So if it gets renamed to Steve, fleet in this case, then the client will find out that you renamed it to Steve within a couple of seconds. And the thing is, when you're looking at a method like this, is this happening on the client or the host? Well, both. It's going to come into this method and then stop on the host in this particular case, but it's going to at least try on both. And so you're going to want to make it to I lost my train of thought. I apologize. Well, at any rate, there are a few things that are like, well, you don't really need to send a game command about it anymore. Certain rules get relaxed a little bit, especially when it gets to dealing with the world and the faction. And when I talk about the world and the faction, I also mean your base info for the world and the faction. So if you've populated your list of trains, or you've assigned a new train and a new guard to it, you don't need to tell the client. You don't need to do that through a game command. That stuff typically does happen in deep info. Hi, you are now a guard for this train. I just created you. When you create it, so here, here's, I think, kind of a last point, which has to do with when you initialize base info on squads in particular. So Badger had noted before that he took the idiom of just kind of, there was no rush on implementing squad base info. He could just kind of put it on there whenever. And to, the most part, that's true. You really can. You can wait and put it on in a later frame. But if you create the squad and then immediately attach whatever its initial info is, like, hi, this is my new train guard. It's a guard of this train. Then in the fast blast initial data that the host sends over to the client, that initial data will include the fact that this train guard is a train guard for that train. If you don't initialize that right away, then that won't be in the fast blast data, and that train on the client, that guard, will think it has no train it's guarding. It was never set to be a guard for anything as far as the client knows. And so any of that information, if it affects unit behavior, and that behavior is happening in base info, meant to happen on the client and the host, they're going to desync over and over and over again. And this is the sort of thing we used to run into before the Great Refactor. It's actually really important. So if you're lazy putting, and I say lazy not in a pejorative sense, but lazy initializing is a term where, like, and we intentionally lazy load some certain squads and stuff that's very advantageous at times. But if you use that strategy when you're initializing squad data, if that squad data is meant to be kept in perfect sync on base info, it's very, very hard to do that, first of all. If you've got information that is so let's say you've got a transport, okay, and it fills up with some units of cargo, and then when it's full, it decides to go somewhere else, and then once it gets there, it empties it, and then it goes, from there, and it goes somewhere else and fills back up. Okay, let's say that's our scenario. All of that would be in base info. It's because everybody should be able to hover over it and see what transport's carrying, but in the tooltips. But if you try and say, I would like to minimize sync issues by making it so that we run all that logic in the stage 3 of base info, almost always that's going to be deleterious, because when you have to assume that the client is in a state of partial desync. And if it's off even a little bit of like, oh, I filled all the way up, that sort of thing, it's going to make a different decision on the client. And the thing is, when the client is thinking about, hey, I'm going to give orders to this ship, and it gives orders to a ship prematurely, then that's when you get into repetitive rubber banding. So that's kind of back to like the engineer example that I gave, except now this is a you thing. So that would be a really, really good way to get yourself into having a lot of bandwidth getting sucked down into a big rubber band mess because of it going, okay, I'm filled now. I'm going to go. And the host is like, what are you talking about? You're not filled. You're out of position. Go back. And the client goes, all right, I'm filled now. Let's go. And then the host is like, what's going on? If there's something blocking it from filling on the host, but the client is not able to know, then you run into that. And those are two ifs. But those are ifs that happen. The more complicated your faction is, the more ifs there are. And if you're relying on squad data being up to date, then essentially, if you think that your base info is going to run perfectly on every squad in your faction, you are relying on only this part of the simulation, and that's not wise, because floating point issues, threading issues, random timing issues, I just wouldn't trust it that way. And if you are dealing with it at a faction level of like, oh, our faction has this amount of resource X, then that's going to be automatically synced over really, really frequently, and you don't have to worry about it. Same thing if you put something in the world. But if you're putting it on the squad, we're talking about like a transport of resources here, or something along those lines, now you've got a problem. So it's notable that the fire team logic, which has a lot of targeting information and other things that are highly contextual, it exists on the client so that they can see when they hover over the mouse info, but we don't rely on it being correct on the client. We run that in deep info, stage 3, even though theoretically we could run it on stage 3 in base info, but it's just so unlikely that it would be reliably correct. We would be generating more garbage and lots of rubber banding if we were to put fire teams in there. We would have crazy amounts of rubber banding, and we used to, actually. Where AI ships that are in a fire team come in and seem to make wildly different choices because of stale data on the client. Because because squad data, especially that is in base info, will get stale. You kind of have to assume that squad data on the client is at least a little bit stale. So if you've got some, if this situation, then make a choice that's based on faction central information in base info, that's been fully synced within the last 2 seconds. If it's on a squad, it may either, one, never have been synced because it was done after the fast blast happened, and then it's never had a desync in position or health before, so there's just not that information on the client. Or it may have a incorrect information because whatever, like filling up process or something, just there was a divergence in data and butterfly effect, and so you can't trust that. And that's hard to, that can be a little bit hard to wrap your mind around sometimes, of like, when is it a problem, when is it not? But you have to imagine the flow of data there, and it's like, This is why I spent so much time on when things are synced, because the fact that squad data is only synced when the position or health is off means that all your beautiful, custom data and base info, stuff about what it's transporting, all of that, as soon as somebody mouses over it, they're going to see the right thing. So from a visual perspective, we're good. But if it's used for squad decision making, you're really relying on the perfection of your code in a way that you probably should not if you use stage 3 base info for much other than like basic attritioning, basic allegiance stuff, etc. That's why most of the logic in general is in stage 3 of deep info. And so back to our transport example. Okay, we don't put that in base info, because if we put it in base info, then we get a rubber band effect sometimes where the client thinks it needs to do something and proactively does something wrong, which the host then corrects, which the client then tries to do again, and we get a repetitive rubber band. That's the worst case. A less worst case is we've got our logic in deep info. The client doesn't run that. The host correctly decides to do something with this ship because it's finished filling up its its cargo or whatever, and it's now about to fly off somewhere else. And so the host says, okay, here's your orders straight from deep info. And since this is the orange section, that's okay. Except it's also a desync, right? Because it just gave orders from deep info to the squad. But is it really a desync? How do you want to give that stuff in? I propose that you don't send a game command, because that's going to make it look laggy. That's going to give a 400 millisecond delay of where it sits there and then goes over after that length of pause, where it then starts flying again. So if you want it to stay nice and reactive, then what you should do is just when you're giving it commands over here, and you're coming from deep info, just mark it as needing a full sync from the host. You've already got some logic that's saying like change my cargo around in a certain way, and then once it's like, okay, this is significant enough changes that we're about to start flying differently, you hit mark as needing full sync. The client is up to date in under 100 milliseconds probably, and things will happen identically on the client and the host. What's the consequence if you don't remember to do that? Well, it's not too bad, really. The host will see everything happening perfectly. The client, assuming this ship is just like sitting stationary, like waiting for something to happen, and the client's not going to be able giving a transport ship any information if that's being routed around by deep info in your custom faction here. So it's just going to be sitting there. And then all of a sudden, the host and the client, within 2 seconds, are going to notice that the position's off, and the host is going to go, oh, you need the new position. Here it is. And so this process will have kicked in. The client will then either see one of two things. If the cargo ship is slow enough, if it's like a tug and it's moving really slow, then the client will just see it zip over here a little bit faster than the tug would normally move, and then resume trudging along. If it's a fast cargo ship, then the client will see it just sitting here, and they'll suddenly see it just over to here all in one zip, and then it'll move at its regular speed from then on. So you'll see artifacts on the client, but it's one of those things where, how many multiplayer games have you played? Like, artifacts happen in every multiplayer game, especially like action games and stuff. You're used to being out of cover, seeing somebody who's about to shoot at you, and then jumping back behind a wall, and then hearing the gunshot, and then you die behind the wall. That's like a thing that happens, right? And we accept that as being part of, well, there's some lag between us, So people don't get too bent out of shape about that. It would be nicer if that didn't happen, but it's not a crisis or a like major defect in the product, and especially in a mod product, so those are the situations in which that's how data moves, really, is what it boils down to. That's how the data moves. You have to think about the implications of fast, this constant syncing and overriding that's happening on world, faction, and fleet, and then the fact that squad is stale very often. Think about how quickly you're initializing your squad data, and does that matter? It may be that lazy initialization is fine. If it doesn't impact any client-side decision-making, automated decision-making, then it doesn't matter. If it's affecting the UI on the client, also doesn't matter, because the client can hover over it. Now, if you let's suppose let's take one more example, and then I'll wrap up. Let's suppose you have a Cargo Empire custom mod faction that you've designed, and it's got 15 different kinds of resources that are being transported all over the place, and they're all on a bunch of different planets. On the client, if you were to go and hover over any cargo tug in that empire, you would immediately see the correct information about what that tug is carrying. Hooray! It works. If there is a custom window that you've added, which is like status of cargo, like status of resources, and it's got like a breakdown of how much of each resource is in transit, how much is stored at each planet, how much is maybe you've got a custom galaxy map view that shows how much cargo is present on each planet. That's going to be stale. It's going to be as recent as the most recent desync that each individual squad had. So, or the most recent time you hit mark as needing sync on there. If you've been coding this theoretical cargo empire in base info only, then it won't be stale, but the odds are you're going to have rubber banding all over the place, so that's not good. Or your code is perfect, and congratulations to you. You're very, very good and very also lucky. Congrats. But more realistically, you're having rubber banding probably, and but your overall roll-ups are going to be correct. This same cargo empire design, there's two ways to handle this. One is you can try and make sure that all the tugs are updated at every point. How many tugs do you have? If it's like 100, that's not really that big a deal. We're talking about like 30 bytes, making sure those get updated fairly frequently. And so like every time they change a planet, maybe call force sync from the host. Certainly every time they're getting new orders, call force sync. If the cargo they have affects the position they're at, then that will happen whether or not you intentionally call force sync, because the client will wind up being out of position slightly, the host will notice, and it'll correct itself within 2 seconds. So you might have, in that situation, up to 2 seconds of stale data. But where you've got a problem, though, is like depots or something like that, like storage containers. If you've got transports that are going over to a storage container and dumping something in it and then leaving, the storage container assumedly doesn't move, can't move, it hasn't been shot. So until somebody goes and mouses over it, that data is never going to the client. So that data will always be stale on the client unless you choose to sync it or unless a client mouses over it. This is okay, assuming that you don't have any roll-ups, and you're not trying to show your disposition of your 15 resources in aggregate by planet or in general or something like that, then it doesn't matter, because from a tooltip perspective, you just go and you hover. But if you start trying to show aggregate data, now you've got a problem. And there's two possible solutions to that. One is that you can every time a transaction happens with your custom resource and an immobile object or any object in your empire, you just fligger. I don't even know if there was. You just trigger a sync on everybody who's involved, so the client knows, aha, here's the most recent info on them. And incidentally, if you trigger like 4 different syncs in the same frame for that depot, for that like cargo depot, because a bunch of cargo ships is pulled up, it'll only send 1 copy of that, so you don't have to worry about flooding it within reason. If you try and do it like every frame, then you could have a problem. Anyhow, so that would be one strategy. The other strategy is if you really only need like top level aggregations, like kind of like we do for how much metal does a player have, how much energy do they have? Well, we put that information on the faction, and that gets synced over to the client very frequently. And if you had like a roll up of some kind, like a planet info thing that says like how much of each resource is being stored at each planet, then that might seem like redundant data. It might actually be redundant data, like it's just for your convenience calculated sort of data. But you could calculate that on the host only in deep info, store that on base info, and this seems to violate something I was saying before, right? I just said calculate it on deep info, store it on base info. In my other video, I was warning you against doing that very thing, and that is true most of the time. But this is one of those times where this is preferable because you're doing an aggregation and then you're updating it into base info. Base info for a faction will automatically be updated probably within 2 seconds, definitely within 5. And so the client will have a slight lag on what they're seeing. It's like being not on the floor of the stock market, but being somewhere else in the world. Very, very slight lag in this particular case. No biggie. And so that is a really clear exception to my earlier rule. Now, you could route that through a game command, but then that's just going to add the lag for everyone. That actually adds more data, because if you have a big, fat game command with a bunch of data in it about planets and info, and you've got all this stuff in there, that's now extra data that you are having to send that wouldn't be sent already. If that data is stored in base info all the time, then for better or for worse, that's being sent every couple of seconds anyway. And so you can just hitch a ride on the data that's already going. Update it on the host from deep info. It'll flow during this particular sync of the faction sync specifically, and it'll show up on the client. And so the client will be a second or two behind on what they're seeing on the per planet aggregate stuff, but all of their general views, if they're looking at your custom galaxy map filter or whatever you've got going on, they're going to probably look pretty correct. So that would be one way to solve it. The other way, if you are rolling it up in real time on that view, would be to flag the squads as their inventories change. So that gets to kind of a disconnect. And by understanding how the data flows, my hope with this video was to impart know when to break the generalized rules that I set, and those sort of roll-ups, that's a good example of one, and not putting stuff that might be relying on stale data in base info, not putting that sort of logic in there, but instead putting it in deep info. Those sort of things seem like they would introduce more entropy, but the client is more likely to make a mistake if it's doing too much, and that's more likely to look weird than it is if the client doesn't know to do something and the host does it and then the client catches up. The second scenario is better than the first one. If the host does something and then tells the client about it as quickly as possible, that's the ideal situation. So those are kind of your three scenarios, and it goes, from most janky looking to looking imperceptibly like it looks as correct as we possibly can. Probably looks perfectly correct. So yeah, that's a lot of scenarios, and there are going to be a bunch of other little edge cases where you're looking at your data and you're thinking, what is the best way to handle this? Like, how is the client supposed to know about this? Or I already coded this, and a client and a customer is telling me that when they play multiplayer, their clients are having really stale data on the Galaxy Map view, and that's frustrating for them. They want to use my mod and they want to have up-to-date information. How do I fix this? Well, you think about how the data flows, and you do one of a few things, which I just outlined. You either move where that logic happens, you make a roll-up and have the host pass it, or you have the host on transactions or whatever the key moments are, trigger a sync to the client, or you stop lazy populating data. Or if you are lazy populating data, then on lazy population, you trigger a sync. That's fine too. That's more data than having it ride the fast blast across, but it's not much more data. Come on, we can afford 30 bytes, Of course, that sort of thinking in aggregate, when you've got thousands of units, can lead to a real, it's only a wafer thin mint, sort of problem where, you're running at, twice the bandwidth you need to because of, it's only 30 bytes on 1,000 units. But generally speaking, it's okay. So, yeah, thank you for listening. I'm sorry that was so long. You can see why I can't draw that. It's very, very situational. So hopefully that made sense. And if you have questions or want my opinion on a particular use case, hit me up on Discord. Thanks.